Hello guys, welcome to our YouTube video, and in this YouTube video we'll be learning about fractions. Okay, so to help us with this, we'll first be learning what fractions are, and then we'll learn the types of fractions that exist, then how to change mixed numbers, which we'll see is a type of fraction to single fractions, how to obtain equivalents of fractions, how to reduce fractions to the lowest terms, and how to arrange fractions in ascending or descending order of size, how to add, subtract, multiply, and divide fractions. And to help us with this, our textbook of reference will be the New General Mathematics for Junior Secondary Schools, Book 1. This textbook is referenced in our description using the Harvard referencing style. Okay, so let's get right into the business of the day. Now, what are fractions, right? So fractions really are just numbers that we use to describe quantities when whole numbers cannot do the job. Okay, like what we have in this picture, for example, is not one whole orange, but an orange that is cut right in the middle. So it's cut right in the middle so that we have half of an orange. That is 1/2. Okay, so we can see that this is one whole orange. So in order to describe or give an accurate description of what we have in this picture, we say that it is half of an orange. And to talk about parts of a fraction, we see that the upper part, which is this right here, is called the numerator, and the lower part is called the denominator. Okay, and types of fractions. The first type of fraction that we have here is mixed numbers. So as the name implies, mixed numbers are really a mixture of whole numbers and fractions, as we see here. In this picture, what we see is 2 oranges and half of an orange. So we can't say that we have 3 oranges here because we just have 2 whole oranges and 1 orange that is cut in half, right? So what we do here is say that we have 2.5 oranges, right? We say it like this, we have 2.5 oranges. Okay, and we write it like this, 2.5, or we say 2 whole number, 1/2. Okay, now we're doing this using whole numbers and fractions together, because this gives the best description of the quantity of oranges that we have in the picture. Okay, and then the second type of fraction we have here is proper fractions. Now, fractions for which the denominator, which is this, remember the bottom part, is bigger than the numerator are called proper fractions. Okay, denominator is bigger than the numerator, so we call them proper fractions. And then the next type of fractions is the improper fractions, just the exact opposite of the proper fractions. We have that the denominator is smaller than the numerator. Okay, so we call we'll call this an improper fraction. Okay, now we'll be getting into the calculations part, but we'll be learning how to change mixed numbers to single fractions and how to change single fractions to mixed numbers. We would also see in the course of our calculations that only improper fractions can be expressed as mixed numbers, and we will learn why. So let's get right into the calculation. All right. So we're going to do some examples where we will be seeing how we can change single fractions to mixed numbers and how we can change mixed numbers to single fractions. Okay, so we'll start by learning how to change mixed numbers to single fractions. Okay, so express the following mixed numbers as single fractions. Okay, now we have one, say 3.5, 2, 4 whole number 2/3, and 3, 5 1/3, 5 whole number 1/3, and fourth one 6 whole number 2/3. Just gonna write this properly. Two over 3. Okay, so we have our solution. Okay, now, so the first one, let's listen carefully, pay attention. So in order to change this mixed number to a single fraction, or in order to express this as a single fraction, what we first do is to multiply the denominator by the whole number part. Okay, that's 3 times 2, which gives us 6. And then we take this 6 and add it with the numerator right here. That's 6 plus 1. It gives us 7. So we say 3.5 equals this number, which we get here. That's 7 divided by or over the same denominator as before. So we say that's 2. Okay? So for the second one, 4 whole number 2/3. What we do is we say 3 times 4, just as we did before. 3 times 4, which gives us 12. And then we say 12 plus 2, which is the numerator, to give us 14. And then we take the 14 and put it over the denominator, so that we have 14/3. And then the third example, just 5 whole number 1/3. Pretty much what we did in the previous ones. Remember, we're multiplying the denominator by the whole number parts. So that gives us what? 15, right? 3 times 5, 15. And then we see that 15 plus 1 gives what? 16. So we say this is 16/3. Okay, and then the fourth example, 6 whole number 2/3. What we do is we say 6 times 3 equals 18. And then we say 18 plus 2, which gives us 20. So we say 6 whole number 2/3 equals 20/3. Okay, so that's pretty easy, right? And let's give you one mixed fraction to see if you can express it as a single fraction by yourself. Okay, so we just write 5 here. So let's see if you guys can do this by yourself. 7 whole number 2/3. So you express this as a single fraction. Okay, so if you got okay, well, you can pause the video and then work it out yourself, and then replay the video to check the answer. So if you got 3 times 7, 21, 21 plus 2, that's 23. So if you got 23/3, you are absolutely right. So great job. Now we want to look at the other part. Want to look at the other parts where we learn how to change single fractions to mixed numbers, so we're just going to clear this. Okay, so we get right into the other part, how to express single fractions as mixed numbers. So first we have 7/2. Second we have 14/3. And third we have 19/2. Okay, so we're going to work with these three examples. So let's do our solution right here. Okay. So how do we change 7/2 to a mixed number? Now the first thing you want to do is to divide 7 by 2. Now we know that 7 divided by 2 equals 3. But it's not exactly 3, as 7 divided by 2 is 3, but with a remainder of 1. Okay, right? How is the remainder 1? Now the remainder is 1 because 3 times 2 equals 6, and 7 minus 6 equals 1. So that's how we know that 7 divided by 2 equals 3 with the remainder of 1. Okay, so that's pretty straightforward, right? Alright, so we'll just erase this. Okay, so now we know that 7 divided by 2 gives 3 with a remainder of 1. So this 3 here is what we'll take to be our whole number parts. Okay, and then we simply rewrite the denominator here, and then we take the remainder, which is this one right here, as our numerator. So now we have fully gotten our mixed number. So we say 7/2 is equal to 3.5. Okay, so let's do the second example. 14/3. Same thing we did in the first one. 14 divided by 3 equals what? Equals 4, with the remainder of what? Remember, 4 times 3 is 12, and 14 minus 12 is 2. So the remainder is 2. Okay, so we say that our whole number part is what? This 4 right here. And we retain our denominator as 3 and our numerator as 2. So say 14/3 expressed as a mixed number is 4 whole number 2/3. And the third one, which is 19 divided by 2. 19 divided by 2 equals 1. Remember, 19 divided by 2 is 9, but with the remainder of 1, right? Because 9 times 2 equals 18, and 19 minus 18 equals 1. So we write our 9 here, we retain the denominator, and take our 1, which is this right here, as our new numerator. So we say 19/2 equals 9.5. Pretty easy. So you guys are going to try this one by yourself. Let's say express 11/3 as a mixed number. Expressed as a mixed Okay, so you can pause the video and work it out yourself before I reveal the answer. So I'm going to reveal the answer now. So if you got what? 3 whole number, 2 over 3, you are absolutely right. Okay? Because 11 over 3 is equal to a 3 whole number, 2 over 3 when expressed as a mixed number. Okay, so now that we're done learning how to express, oh yeah, there's something we're missing. Okay, I told you I was going to tell you why only improper fractions can be expressed as mixed numbers. Okay, so only improper fractions can be expressed as mixed numbers. Why? Okay, now if you take a look at all the fractions that we had here, we'll see that all of them are improper fractions because the numerator is smaller than the denominator, I beg your pardon, is smaller than the numerator. Okay, now this makes a lot of sense because we see that in trying to divide the numerator by the denominator, for us to have a whole number parts, the numerator has to be bigger than the denominator. If the numerator were to be smaller than the denominator, we wouldn't have a whole number if we divided the numerator by the denominator. Okay, so this is the reason why only improper fractions can be expressed as mixed numbers. So I hope you understand that. Okay, so we'll get right to the next part of the lesson. So we're just gonna clear the canvas here, and then we'll go to the other parts of the lesson. Okay, so the next part is equivalent fractions. Now, equivalent fractions are fractions that have different numerator and denominator, but represent the same value when simplified. For example, 1 over 3 and 2 over 6 are examples of equivalent fractions, as we will see later in the course of our lessons. So we see that 1 over 3, the fraction 1 over 3, has a different denominator and numerator from the fraction 2 over 6. But we see that they are equivalent fractions and they represent the same value, right? Because when 2 over 6 is reduced to the lowest terms, we see that we get 1 over 3. We will learn in the course of our lesson how to express fractions in their lowest terms. And one important principle of fractions to know is that if you multiply the numerator and the denominator by the same number, you get an equivalent fraction. For example, if you had a fraction, say x over y, for example, multiplying x by n, let's say any number called n, and y by n gives you x over y. The fraction remains unchanged. It gives you xn over yn, but xn over yn is still the same thing as, or still represents the same value as x over y. We will learn this in the course of our lesson. Now, talking about lowest terms, in order to express a fraction in its lowest terms, all we simply need to do is to divide the numerator and denominator by the common factors. So we'll continuously divide the numerator and denominator by the common factors until there is no common factor with which we can divide both the numerator and the denominator. So in case you're wondering what a factor of a number is, a factor of a number is another number which can divide a number without any remainder. For example, 6 divided by 2 equals 3 without a remainder. So we say 2, which can divide 6 without a remainder, is a factor of 6. So we say 2 is a factor of 6. Okay, so now let's do some practical examples with equivalent fractions, and we'll also be learning first how to express a fraction in its lowest terms. So we'll go back to our whiteboard. Okay, so we are in a whiteboard and we want to learn how to express fractions in the lowest terms. So say we had a fraction 16 over 18, for example. We had another one 20 over 30. We had another one 15 over 18. And we had another one as 40 over, let's say, 100. Okay, so let's express all these fractions. Let's express all these fractions in their lowest terms. So how do we begin? Now remember, the first thing you want to do is 1. Okay, let's say solution. So first thing you want to do, first step, is to divide both numerator and denominator by their common factors. Okay. And the second thing you want to do is to repeat step 1 until, sorry, this is until, okay, until there are no until there is no common factor. Now, remember, a factor is a number that can divide another number exactly without a remainder. Okay, so it's called a common factor when it is common to both the numerator and the denominator, meaning that when it can divide both the numerator and the denominator without leaving a remainder. Okay, so for example, since 6 and 8 are divisible by 2, since 6 and 8 are both divisible by 2, we say 2 is a common factor of 6 and 8. Okay, so that's the simplest definition of common factor. Okay, so we're just going to erase this so we have some space to do our work. Alright, I'm just going to erase this right here. Okay, so we start with the first one, which is 16 over 18. Now remember, the first thing we want to do here is to divide by the common factor. And common factor of 16 and 18 is 2. So we can just draw a neat stroke here over 16. So draw a neat slash over 16. That's 16 divided by 2, which is 8. And another one over 18 divided by 2, which is 9. Okay, so and now we see that there is no other number that is common to both 8 and 9. Okay, there's no other factor that is common to both 8 and 9. So we'll stop here. So we say 16 over 18 expressed in its lowest terms is 8 over 9. Okay, and then 20 over 13. So we start by the lowest common factor, which is 2. 20 divided by 2, that's 10. 30 divided by 2, that's 15. 10 divided by 5, that's 2. 15 divided by 5, that's 3. So it says 20 over 30 equals 3. Now, another easier way that we could have done this would have just been simply to cancel out the zeros and to say 2 over 3. So when we have fractions like this, where we have zeros in the numerator and the denominator, that's after all the whole numbers. Remember, it has to be after all the whole numbers. We can just simply cancel out the zeros. For example, if we have 400 over 200, we can just simply cancel out all the zeros and write it as 4 over 2. Or if we have 200 over 400, we can simply cancel out the zeros and write it as 2 over 4. Or if we have 300 over 700, we can simply cancel out the zeros and write it as 3 over 7. Now remember, I said all the zeros have to be at the end of the non-zero numbers. Okay, meaning that you can't, if you had a fraction such as 406 over 700, you can't do this. You can't cancel the 0 here and cancel the 0 here. No, that will be wrong. Okay, this is something that you should not do. Okay, the zeros that you can cancel are only zeros after the non-zero numbers and don't have any non-zero numbers accompanying it. Okay, so the only zeros that you can cancel are zeros after the non-zero numbers and zeros that do not have any non-zero numbers following them. Okay, same way you can also say 320 over 705, for example. You cannot do this. This would be absolutely wrong. Okay, it is only zeros that are after the non-zero numbers and do not have any non-zero numbers following them that you can cancel out like this. Okay, so we're just gonna erase. So I'm just going to erase this to make some space for another example. Alright, so now the third one is 15 over 18. How do we do this? Now the first thing to do, remember, divide by the common factor, which is 3. 15 over 3, that's 5. 18 over 3, that's 6. So this is equal to 5 over 6. Simple, right? And the last one, which is 40 over 100. Remember what we learned. So we can cancel out the 0 here, right? And I can see 4 divided by 2, that's 2. 10 divided by 2, that's 5. So we have this as 2 over 5. Now you can try this on your own. 5, which is, let's say, 90 over 60. So you can express as a single fact, in its lowest terms. Express this in its lowest terms. So this you can try on your own. So you can pause the video to give yourself some time to try it on your own while I do the solution. So first of all, we can cancel out the zeros, and then we can divide by 3. So 9 divided by 3, that gives 3 here. 6 divided by 3, that gives 2. So this is 3 over 2. And we know that this is an improper fraction, right? Because we have that the denominator is smaller than the numerator. So we can still express this as a mixed number. So remember what we do. We say 3 divided by 2, that's 1. We retain the denominator, and then it has a remainder of 1, right? So we just simply write it as 1 whole number, 1 over 2, or 1.5. Okay, so now that we understand how to express fractions in their lowest terms, we can refer to our example in the slide where we said that 1 over 3 is equal to 2 over 6. So we now see that 2 over 6 expressed in its lowest terms, dividing here by 2, it gives us 1, dividing here by 2, it gives us 3. So we see that 2 over 6 equals 1 over 3. Okay. So we can simply clear this space and then move to the next one, which is equivalent. Equivalent fractions. Okay. So remember, we said that the law of equivalent fractions, or the fundamental principle of fractions, is that if you multiply the numerator and the denominator of any fraction by the same number, we get the same fraction. Okay, this is still the same thing as x over y. Okay, now using numbers, if we had a fraction like 2 over 9, so we multiply 2 over 9 by 2, the numerator in 2 over 9 by 2 and the denominator by 2, we'd have 4 over 18. If we decide to reduce to the lowest terms, we have what? 2 over 9 again. Okay, we have 3 over 4, and we multiply both the numerator and denominator by 3. We have what? 9 over 12. And if we were to reduce it to its lowest terms, we have 3 over 4. Okay, so we have now successfully demonstrated the principle of equivalent fractions. Okay, so let's do a simple exercise involving the principle of equivalent fractions. Okay, so Say we had 1 over 3 here equals 3 over 9 equals 6 over blank space equals empty spaces. How do we fill them? Alright, so our focus will be on the first fraction, which is 1 over 3. In order to solve this, in order to solve to get the numbers and the missing spaces. Now remember our principle of equivalent fraction, that you multiply the numerator and the denominator by the same number so that you have an equivalent fraction. Okay, meaning that if you multiply 1 by 6 to get 6, you must also multiply 3 by 6 to get whatever number is missing here. So what we do to get this missing number is to say 6 divided by 1 here to give us 6. 6 divided by 1 to give us 6. And then we multiply this 3, which is this number right here, by 6 to give us 18. So the answer here will be 18. The same thing we do in the second one. Now this one here, remember our point of focus would be the initial fraction, which is 1 over 3. We say 24 divided by 3, which gives us 8, right? And then we say 1 times 8 gives us what? 8. So the answer here will be 8. Okay, and then same thing we do for this one. 50 divided by 1 gives us what? 50. So 50 times 3 gives us 150. So the answer here is 150. Okay, and here, same thing. 90 divided by 3 gives us 30. Say 30 times 1 gives us 13. So say this is 30 right here. And 100 divided by 1 gives us 100. So say 100 times 3 gives us 300. So say just 300 here. So that's how to solve a question like this. Okay, so we'll move on to the next part, which is arranging fractions in descending or ascending order of size or magnitude. So we're just going to clear this whiteboard here, and then we'll move to our slides. Or arrange fractions, I'm sorry. In ascending descending order of size. Now, the ascending means what? Lowest to biggest, or highest. I think we should say highest here instead. And lowest to the highest or smallest to the biggest, and descending is what? From the highest to the lowest, or from the biggest to the smallest. Okay. Alright, so let's look at a couple of examples, right? And see how we can do this. Now, example. Arrange the following fractions in ascending and descending order. Okay. Now, so what we have here is 3 over 4, 5 over 8, 7 over 12, and 2 over 3. So how do we do this? So the first step, of course, is to find the lowest common multiple or the LCM for short of the this is just gonna write this out easily. Of the denominators. Now the denominators are 4, 8, 12, and 3. So we're going to find the LCM of 4, 8, 12, and 3. Okay. So how do we do this? So the first thing we want to do is to draw a table like this. Okay. And then you write the denominators, the numbers again. Just write them out neatly. And 3. Okay, so first of all, we start with the lowest common factor, the lowest factor, which is 2. Okay, that's 2. So we say 4 divided by 2 gives us 2 here. 8 divided by 2 gives us 4. 12 divided by 2 gives us 6. 3 divided by 2. Now 3 isn't divisible by 2, so what we do is that we just simply write it down as 3. Next, we divide by 2 again. 2 divided by 2 gives us 1. 4 divided by 2 gives us 2, so write that here. 6 divided by 2 gives us 3. 3 divided by 2 isn't divisible by 2, right? So we write it down again. And then we use 2 again. 1 divided by 2, 1 isn't exactly divisible by 2. So write it down again. Now 2 divided by 2 gives 1, so write that here. 3 divided by 2, not divisible by 2 without a remainder, so we write 3, and we write 3 here again, same reason as before. Now we use 3 now because 3 is a factor to both this number here and this number here, so we say 3. Now 1 isn't divisible by 3, so write it 1, same here. 3 divided by 3 is 1, 3 divided by 3 is 1. So we stop here where you have all these numbers here as 1. This is where you stop. Now to get the LCM, what we do is multiply all these numbers, right, from here to here. So we say 2 times 2 times 2 times 3, which is equal to 24. Okay, so the LCM of 4, LCM, which is lowest common multiple of 4, 8, 12, and 3 equals 24. Alright, so now the second step will be to express all the fractions with denominators of 24. So I'm just going to clean this so we have space for second step. Remember, our LCM of 4, 8, and 12, all of the denominators is 24. So we just write this here. LCM of denominators is 24. Okay, so I'm just going to say second step. Express each fraction with a denominator of 24. Now to express 3 over 4 as with the denominator of 24, remember, if you multiply the numerator and denominator by the same number, you get an equivalent fraction. Okay, so now what number can we multiply 3 and 4 together with to give us a fraction which has a denominator of 24? Now, remember what we did in the previous example. What we say here is we do 24. What we do here is that we do this 24 divided by 4. That gives us 6. And then we say 6 times 3 right here gives us 18. Okay, so this is what we do. So we have that 18 over 24 is the same thing as 3 over 4. Okay, that's the same thing we do with the other fractions. 24 divided by 8, that's 3. 3 times 5 is 15. So we have this here. And then for 7 over 12, so this is 14, because 24 divided by 12 is 2, and 2 times 7 is 14. And then 2 over 3, I'm sorry, it's a mistake. Just going to erase it. over 24, right? 24 divided by 3, that's 8, then 8 times 2, that's 16. Okay, so we have our equivalent fractions as what? 18 over 24, 15 over 24, 14 over 24, and 16 over 24. Now, how do we arrange in ascending or descending order? So what we'll be focusing on now, since we have all the denominators as 24, is that we'll be focusing on the numerators alone. Now, the numerators here are 18, 15, 14, and 16. So to arrange them in ascending order, just shorten this, ascending order, which we know is what? The smallest to the biggest. The smallest number here is what? 14. So we'll start by 14 over 24. That's the smallest numerator. That's 14. And then the second smallest is what? Or the biggest after 14 is 15. So we'll say 15 over 24. The biggest after 15 is what? 16. So we'll say 16 over 24. And the biggest over after 16 is what? 18. So we'll say 18 over 24. So to arrange in these fractions in ascending order, this is what we do, and then we simply remember this equivalent fractions are representative of what? 14 over 24, that's 7 over 12. 15 over 24, that's 5 over 8. 16 over 24, that's 2 over 3. And 18 over 24, that's 3 over 4. So to arrange in ascending order, this will be the answer. Okay? Not this is not the final answer here. But this right here is the final answer. So do not forget to rewrite. That's after the working. Do not forget to write the actual fractions and not leave it as the equivalent fractions. Okay? So this is the final answer here. Now let's do the descending order. So we're just going to erase this to make some space. Now, descending order, remember, it's from the biggest to the smallest. The biggest is what? 16, right? Remember, we're focusing on the numerators alone. I'm sorry, the biggest is 18. That's 18. My bad. Biggest is 18. So say 18, right? Followed by 16, of course. And then 15. And 14. Now remember, 18 over 24 is what? 3 over 4. 16 over 24 is what? 2 over 3. 15 over 24 is 5 over 8. And 14 over 24 is 7 over 12. So this right here is our final answer. Okay, so now we have learned how to arrange fractions in ascending and descending order. Okay, ascending order of size. Okay, so the next thing we'll be learning is addition and subtraction and multiplication and division of fractions. Alright, so here we're gonna be looking at how to add, subtract, multiply, and divide fractions. Okay, so T here. All right. So first of all, we'll begin with the addition of fractions. So I'm just going to erase all this. So we write a fresh topic. Addition of fractions. Okay. Okay. Addition of fractions. All right. So as we have done with the previous subtopics, we'll start with examples so that we see how to add fractions. So we just give a simple illustration of how fractions are added. Okay, so the first one be 3 over 4 plus 2 over 5. The second will be 5 over 6 plus 2 over 3. The third will be 4 over 3 plus 3 over 5. Okay, so we get right into the solution. Now, 3 over 4 plus 2 over 5. So the first thing we want to do here is to find the LCM of 4 and 5. So we can find the LCM of 4 and 5 as we have done in the previous sections of the lesson. Okay, so just quickly writing that out, the LCM of 4 and 5 is 20. Okay, so in a case like this where you see that 4 and 5 have no common factors, the easiest way to find the LCM is just to quickly multiply 4 by 5 so that it gives 20. That's if there are no common factors between the two numbers. Okay, so the LCM we say is 20. All right. All right, so we're just going to erase this and we're going to write out 20 here because of the LCM. Okay, so the second step will be to say 20. Okay, let me just write this out. First step, find LCM of denominators. Okay. And then the second step after the LCM will be that after writing 20 as the new denominator of the solution, will be to say this 20 right here divided by 4, which gives 5, and then we multiply 5 by 3 to give 15. And then we'll say plus 20 divided by 5, that's 4. And then 4 times 2, I beg your pardon, gives 8. So this gives us 23. That's 15 plus 8, that's 23 over 20. So we have that 3 over 4 plus 2 over 5 equals 23 over 20. All right. Now, if you want to do it this way, say you wanted to do the second, because there's a second method to add these fractions. So say you wanted to do it with the second method. Now, 3 over 4 plus 2 over 5. Now, the second method will simply be to express 3 over 4 as a fraction with the denominator of 20, because the LCM of both 4 and 5 are 20. Now, if we express, remember what we learned in equivalent fractions, if we were to express 3 over 4 as a fraction with a denominator of 20, we'd simply say 20 divided by 4, that's 5, and then 5 times 3, that's 15, okay? And then 2 over 5 will be equal to 20 divided by 5, that's 4, and then 4 times 2, that's 8. 8 over 20. So we can simply take these two equivalent fractions, 15 over 20 and 8 over 20. Now that we have that the denominators are the same, all we just need to do is to add both numerators and then retain the same denominator that we have here. That's 23 over 20. Okay, that's the second method to do this. All right, so let's look at the second example. Okay. Now, okay, this is number 1. And number 2, we have 5 over 6 plus 2 over 3. Okay. So now we were to find the LCM of this. Remember how we found our LCM in the previous video, or previous sections of the video. So we have this as 6 here, and we have 3. Remember to start with the lowest common factor. That's 6 over 2, that's 3. And 3 divided by 2, it's not exactly divisible, so write it down. And then next is 3, right? So say 3 divided by 3, that's 1 and 1 here. So the LCM of both 6 and 3 is 6. Okay, so just like we did in the first example, 6 divided by 6, that's 1. 5 times 1, that's 5. And then 6 divided by 3, that's 2. 2 times 2, that's 4. So we have 9 over 6. And then we can reduce this to its lowest terms because 9 and 6 have common factors, right? And the common factor is 3. So we say 3 goes in 9 to give 3, and then 3 goes here to give 2. So that's 3 over 2, right? And then we can also still express this as a mixed number. So we say 3 divided by 2 gives 1, of course, with a remainder of 1, okay? And then the last example, which is 4 over 3 plus 3 over 5. Now remember what I said. When the denominators, or the denominators don't have any common factor, to get the LCM, all you simply need to do is multiply both numbers. So we'll say this is 15. Okay. And then 15 divided by 3 gives 5, and then 5 times 4, that's 20. And then 15 divided by 5 gives 3, and then 3 times 3, that's 9. Okay. So 20 plus 9 is 29 over 15. So we could leave it this way, or we could express it as a mixed number. And then we say this is one whole number. That's 29 divided by 15, that's 1. But with the remainder of what? 14, right? So it says one whole number, 14 over 15. That's the answer. There we go. So now we move into the next topic, which is, or subtopic, which is subtraction of fractions. So I'm just going to erase this quickly, or better still, I just clear the canvas to make it quicker. Okay, great. So I'm just gonna. Okay, so we're now doing the subtraction of fractions. All right, now as done before, we'll be treating examples to help us understand better. Okay, so let's say the first one is 3 over 5 minus 1 over 2, or half. Second example is 4 over 3 minus 3 over 4. And third example is 5 over 6. Okay, I'm just going to write this out clearly. Five over 6 minus, I'm sorry, 5 over 6 minus 3 over 5. Okay, so let's begin. Solution here. Okay. So this is 3 over 5 minus 1 over 2. So just like we did before, the first thing we want to do is find the LCM. Just like we did with the addition. First thing we want to do is find the LCM. And remember, when both numbers do not have any common factors between them, we simply multiply to get the LCM, and that's 10. Okay, so 10 divided by 5 is 2, and then 2 times 3, that gives 6. 10 divided by 2 is 5, and 5 times 1 gives 5. Right? So that's 10 divided by 5 here, that's 2. 2 times 3 here, that's 6. 10 divided by 2, that gives 5. 5 times 1 here gives 5. So 6 minus 5 equals 1 over 10. Okay, that's the answer. And then this is 1. And then the second example, 4 over 3 minus 3 over 4. Same thing with this one here. Okay, LCM is 12, 3 times 4. Then because they do not have any common factors between them, so we just say 3 times 4, that's 12. So 12 divided by 3, that's 4. 4 times 4 is 16. Minus 12 divided by 4, that's 3, and then 3 times 3, that's 9. So 16 minus 9 equals 7, I believe. That's 7. 7 over 12 is our answer. And then last one, just 5 over 6 minus 3 over 5. Same thing, it's 13. 30 over 5, that's 5. 5 times 5, that's 25, right? 30 over 5, that's 6. 6 times 3, that's 18. So this gives us what? 7. Okay, it's not very clear. I'm going to erase this. Okay. So this gives us 7 over 13. So that's our answer. Now, imagine if we had a question where we had mixed numbers and were to add and subtract mixed numbers. Right? How would we do that? Well, that's pretty easy. All you just need to do is to convert them to single fractions and then do the addition and subtraction straight away. So say we had 3 over 4, 3 whole number 1 over 4 plus say 4 whole number 1 over 5. All you simply need to do is to convert to single fraction first. That's 13 over 4 plus 21 over 5. And now we can easily add them. Alright. That's 20 divided by 4, that's 5. 5 times 13, that's 65, I believe. That is correct. 65. And then 20 divided by 5, that's 4. And 21 times 4, that is 84. Okay, so adding 65 and 84, that gives us 149 over 20. Okay, so this is it. And then say we had say 3 minus 7.5. Okay, convert single fraction. That's 13 over 4 minus 5 over 2. Okay. So what do we do here first? Remember, they have a common factor, which is 2, 4 and 2. So we can't just multiply them to get the LCM. So to get the LCM, sorry, you need to draw your table, find the LCM. Okay. Right, so 30 as 2. Now, if we find the LCM, we'll see that the LCM is 4. Okay. We're going to do this and do this. So let's say that the LCM is 2 times 2, which equals 4, right? Okay, it's a quick one there. And let's erase it. Okay. Alright, so we say 4 divided by 4, that's 1. 1 times 13, that's 13. 4 divided by 2, that's 2. 2 times 5, that's 10. So this is equal to 3 over 4. Okay, so that's how to add and subtract mixed numbers. Okay, so now we go right into the multiplication and division of fractions. Okay. All right. Okay, so let's say multiplication and division of fractions. Right, so first example, okay, let me just write this out. Examples. So the first one we'll be looking at is the multiplication. So let's say 3 over 4 times, what now? Let's say 2 over 9. Second, say 9 over 12 times 6 over 10. And then the third one, which will be division, is 4 over 5 divided by 2, divided by 8 over 2, and then the fourth one, say 9 over 4 divided by 12 over 10. Okay, so let's get right to the solution. Now, first of all, we're starting with the first question. That's the over 4 times 2 over 9. So now what you want to do here is to consider both the numerator and the denominator in each of the fractions, and then see how the numerator in this first fraction can divide the denominator in this fraction here, and how the numerator in this fraction on the opposite side can divide the denominator in this fraction on the opposite side. So I'll take that again. We see how the first fraction, how the numerator in the fraction here on this opposite side can divide the denominator in the fraction on the opposite side as well, and this one here on this side, how this numerator here on this side can divide this denominator on the other side. Okay, so 3 goes here, 1, and then 3 goes in 9 to give 3. Right? 2 goes here, 1, and then 2 goes in 4 to give 2. So this gives us 1 times 1, that's 1, and 2 times 3, that's 6. Okay, so that's the solution. That's the answer right here. And then the second one, which is 9 over 12 times 6 over 10. Now we could just reduce these fractions to their lowest terms, or we could just multiply, or just start multiplying straight ahead. So like we did in the first one, we could say 3 here gives 2, and 3 here gives 4. 2 here gives 1, and 4 divided by 2 gives 2. Now, 9 and 10 do not have any common factors, so we just leave them like that. And then we say 9 times 1, that's 9 over 20. Okay. Now, say we want to solve by putting the fractions in their lowest terms. Now, 9 over 12 in its lowest terms is that's 3 over 4 times, and 6 over 10 in its lowest term is 3 over 5. So now we do not have any common factors between this numerator and this denominator here, so we can't divide anything here. Same thing with this one and this one. This numerator here and this denominator here, that's 3 and 4. So we just multiply together. 3 times 3, that's 9, and 5 times 4, that's 20. Still the same thing. Okay. And then the third one, which is 4 over 5 divided by 8 over 2. Now, when we're talking about division, what we want to do is, the first thing we want to do is that the fraction on this side, the fraction on this side right here, that's this 8 over 2, okay, on the right hand side. What you want to do is to invert the fraction. So once you invert the fraction, you introduce a multiplication sign. So this is what it becomes, okay? And then we can now multiply like we did with the rest. So we'll say 2 goes here, 2, that's 4 over 2. 2 goes here, that's 4. 2 goes here, that's 1. 2 goes here, that's 2. So this gives us 2 over 10, which is equal to 1 over 5. Alright, so we'll do the fourth example, which is 9 over 4 divided by 12 over 10. Okay, so now remember, in trying to solve this, all we need to do is to invert the fraction on the right hand side and then introduce a multiplication sign. So now remember what we did with the previous one. So we look at the numerator on one fraction, that is the fraction on the left hand side, and the denominator of the fraction on the right hand side, and then cancel them out or divide them with their common factors, right? So the common factor between 9 and 12 here is 3. That's one common factor. So we say 9 divided by 3 gives 3 here. And 12 over 3 gives 4 here. That's 3 in 12 gives 4 here. And then 2 in 4 gives 2. And then 2 in 10 gives 5. So multiplying 3 and 5, we get 15. Then multiplying 2 and 4, we get 8. So we say that 9 over 4 divided by 12 over 10 equals 15 over 8. So this is the answer. Now that we're done learning subtraction, addition, division, and multiplication of fractions, we will then move to the next subtopic called order of operations, and we will learn how to use a certain acronym called BODMAS in solving questions under this subtopic. All right. Order of operations. Okay, so say we had a question that involved different kinds of operations: subtraction, multiplication, and division, all together in one question. How would we solve it? Now, there's something called an acronym, actually, called BODMAS. BODMAS helps us to understand the order in which we should answer such a question where we have different kinds of operations in one. Now, B in BODMAS stands for brackets, O stands for order, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. Now, this order talks about the order of the fraction, talks about the exponents or powers or indices on the fraction. So we're just going to look at a simple example to illustrate how we do the order of with this simple example. So we had a fraction 1 over 2, or we have a fraction 1 over 2 plus 3 over 4 minus, sorry, can I write that out clearly? Minus 4 over 3 times 2 over 9 divided by 6 over 9. Now remember, the BODMAS rule says that we should follow the order of operations from left to right when solving questions, left to right. Okay, so we're going to look from left to right and see which one comes first. Okay, and now in our order, the first one that comes is the brackets, right? Left to right, remember. Okay, so we'll solve what is in the bracket first. And now to solve what's in the brackets, To solve what's in the brackets, we have to add 1 over 3 and 3 over 4. So to do this, our LCM here is 4, and then 4 divided by 2, that's 2, 2 times 1 is 2, 4 divided by 4, that's 1, 3 times 1 is 3. There's bracket here, minus 4 over 3 times 2 over 9 divided by 6 over 9. Okay, so we say 5 over 4 minus, that's this one here. Now that we have successfully added the fractions in the bracket, we can remove the brackets. Okay, so write it as 5 over 4 minus 4 over 3 times 2 over 9 divided by 6 over 9. Okay, remember we're looking at the order of operations as listed here from left to right. Okay, so now after doing the bracket, what comes next? We see that it is division, right? So division comes next. So how do we divide? Now remember, we talked about division, right? That in dividing, what you need to do is to invert the fraction that is on the right hand side. So this becomes 9 over 6. Okay, so after dividing, multiplication comes next, right? So we say 5 over 4 minus 4 over 3, okay, times 2 over 9 times 9 over 6. So this 9 here cancels this 9 here, that's 1. This 2, here 1, 2 here 3. So we can say 5 over 4 minus 4 times all these 1s here, that's 1, that's 4, I'm sorry, over 3 times 3, that's 9. So this gives us what? It's just going to come right up here. Let's continue. So I'll just draw a line here. Okay. So that's 5 over 4 minus 4 over 9. Remember, the LCM is 36. And 36 over 4, that's 9. 9 times 5, that's 45. Minus 36 over 9, that's 5. That's 4, I'm sorry. 4 times 4, that's 16. So 45 minus 16 gives what? 45 minus 16 gives us 29. Okay? That's 29 over 36. So the answer to this question is 29 over 36. So final answer. Okay. So now this order here, as I said earlier, represents the order of fractions. That is, the power indices or exponents that a fraction carries. So I'm just going to erase this here and just tweak the question a little bit. So I'm going to resolve this so that we have more space to work. Okay, now say this were a question where we had a power. Say this was, this 4 over 3 was to the power of 2. Now to solve this, what we'll just simply do after adding this one here in the brackets. Okay, so we added this one in bracket first. I'm going to go 5 over 4. To solve this, all we just simply do will be to express this in a single fraction without the index or the exponents. So this will be 4 squared, that's 16, over 3 squared, that's 9, times 2 over 9, divided by 6 over 9, and then we solve as we did before. So that's what the order is. But then in some classes, in some levels, you might not be required to, especially the junior secondary, you might not be required to understand this part. So you just don't need to, you might not need to worry about that for now. But then say you were in a higher level and then you had this exponential, that's the power of 2. What you need to do would be to express it without the power, and then 4 over 3 squared is equal to 16 over 9. Okay. So that's that, guys, with our first lesson of fractions. I hope you learned a lot. So I'm just gonna end the lesson here, and I'm going to say thank you. I'm going to say thank you for watching the video, and I hope you subscribe and check out other videos that I'll be posting. Okay, I'll be posting videos where I'll be working out the questions that are contained in the new general mathematics, working out all the questions, explaining, giving detailed solutions, providing answers, step-by-step solutions and answers so that you might understand various topics. But then in our next lesson, before I start with the solutions, we'll be talking about fractions. The second part of fractions again. We'll be learning how to solve word problems involving fractions, and then we'll also be looking at percentages. So just watch out for the next lesson. Thanks for watching, guys.